We stand at the precipice of cosmic engineering, contemplating a future where the sheer scale of our power consumption matches the stars themselves. To truly transcend our planetary confines and secure our long-term survival, humanity must ascend the ladder of the Kadasha scale, striving for the ultimate designation, Type 2 civilization. This status demands the total mastery and utilization of all the energy radiated by our parent star. The overwhelming solution, the star-sized machine necessary to achieve this cosmic milestone, is the Dyson Sphere. But this concept is far more than just theoretical speculation. It is an exploration into materials science, orbital mechanics, and astronomical logistics on a scale that defies current human understanding. A Dyson sphere is not necessarily a solid shell encasing the star. It's popularized in science fiction. For such a structure would be gravitationally unstable and require materials of impossible tensile strength. The more practical, and arguably more feasible, design is the Dyson swarm. Billions, or even trillions, of independent solar collectors and habitats orbiting the star in a dense network. This decentralized approach allows for construction in stages, maintenance, and minimizes the catastrophic failure risks associated with a monolithic shell. The engineering challenge presented by even a rudimentary swarm is staggering, demanding resources far exceeding everything currently mined on Earth to capture 100% of the sun's output. The collector surface area required is roughly 600 million times that of Earth's total surface area. Consider the materials required for this monumental undertaking. If we assume even a minimal structure, the sheer volume of mass needed to create the necessary reflective and conductive panels is immense. Sourcing this mass from Earth alone would utterly strip our planet bare, rendering the entire endeavor moot from the start. Therefore, the construction materials must inevitably come from non-Earth sources, likely harvested from the asteroid belt, the moons of the gas giants, or perhaps even Mercury, the innermost planet, which is gravitationally easier to deconstruct and already in close proximity to the construction zone. The logistical framework necessary to establish mining operations across the solar system, process raw planetary material into finished components, and then launch and assemble those components into a precise orbital alignment around the Sun, stretches the very limits of our imagination. We would need self-replicating robotic systems, automated fabrication facilities operating on a planetary scale, and energy infrastructure dedicated solely to the construction process. Achieving a Type 2 designation signifies an energy output of roughly $4 times 1,026 watts. It's an amount that dwarfs our current global energy consumption by many orders of magnitude. This energy could power interstellar travel, allow for massive terraforming projects across multiple planets, or even fundamentally alter the laws of physics within a localized area. Such a civilization would possess an intrinsic stability, virtually immune to minor astronomical catastrophes like asteroid impacts or localized stellar flares. Their ability to manage resources and maintain habitable environments would place them in a category far beyond anything we currently know. If the Dyson Sphere is the inevitable structure for any sufficiently advanced civilization, a necessary step in cosmic evolution, then the question naturally arises, have we seen any evidence of them already? This takes us into the realm of observational astronomy and the search for extraterrestrial intelligence, specifically the search for extraterrestrial artifacts, CETA. A complete Dyson swarm or sphere would dramatically alter the spectral signature of its host star. Instead of seeing the expected visible light spectrum of a typical star, the civilization's energy collectors would absorb most of that visible light. The absorbed energy must then be re-radiated, but due to thermodynamic laws, it would be emitted at a much longer wavelength, specifically in the infrared spectrum, corresponding to the temperature of the structure itself. Such a massive, warm object radiating heat in the infrared, yet blocking visible starlight, would present an unmistakable signature. An unusually dim star in the visible band, surrounded by an excess of infrared radiation. This specific spectral anomaly is precisely what astronomers look for when hunting for technosignatures. In 2015, the star KIC 8,462,852, commonly known as Tabby star, provided a powerful, compelling, and intensely debated example of such an anomaly. Tabby's star exhibited inexplicable, massive, and irregular dips in brightness, sometimes dimming by as much as 22%, which far exceeded the predictable dimming caused by orbiting planets. While natural explanations like comet swarms or fragmented planetesimals remain the most accepted scientific consensus, the sheer irregularity and scale of the dimming immediately elevated the possibility of an artificial megastructure, potentially a Dyson swarm in various stages of construction. The debate surrounding Tabby's star underscores the very real possibility that when humanity finally spots compelling evidence of a Type 2 civilization, it will be through the unmistakable, massive engineering project that is the Sphere. The concept of the Dyson Sphere pushes us to confront the true potential of our species, requiring us to think in terms of generational projects, resource allocation on a stellar scale, and the ultimate destination of technological progress. It is a mirror reflecting what we could become if we successfully overcome the limitations of scarcity and political division. The journey from a fragile Type 0 civilization to a robust Type 2 power is fraught with challenges. Yet the ultimate prize is near immortality for our species within the vast, indifferent cosmos. To delve deeper into the astonishing engineering required for these cosmic megastructures, and to explore the latest findings on potentially alien construction projects, make sure you are subscribed. You do not want to miss the next episode on Infinitoinial.